Right, good afternoon, learners. This is IT Grade 11. My name is Mr. Freeman. It's Friday, the 22nd of May, just about 2 o'clock. And we're going to carry on with our topic for functions and procedures or user-defined methods. And today I'm going to show you validation and throw that in the mix. Just show you what different types of validation there are, why it is important, where you would need it, and we will incorporate that into functions. Now, today's lesson, I don't think we're going to get to Delphi. I'm going to go through certain theory behind validation and show you example code on this PowerPoint. But I think that will probably be all for today. And then on Monday, and possibly moving on to Tuesday, we will then go and take everything we've learned today and implement that into quite a large Delphi project. Okay. So yesterday, what did we do? So we did the whole idea of functions. Now we've done procedures the previous 2 days. And then yesterday, I introduced you to functions, and we defined a function. I showed you how to declare the function. And being that it is a function that returns something, we had to do the actual return types. Where do I tell the function what you're going to return and the actual return type? And if you remember, so it's at the top when I define my function, right at the end with my colon, and is it a string, is it an integer? And that's the one part of my return type. And the second part of the return type is at the end of the body of my function's code, I have to always return that value, and we use the result becomes and then that value. So if it was a string type, you got to return a string, and so on. Yeah, we looked at functions with and without parameters in our Delphi example yesterday. We did it with two functions with parameters, but the without's even easier. Doesn't need any additional information to do the task. But we could possibly see if we can make a function without any parameters on Monday or Tuesday. And as I said, we implemented this in Delphi. I also discussed some very important rules when it comes to coding methods. Please, if you forget, go back to YouTube, wherever you can get these videos from, and just go through them again, those rules. I think they're quite important. And then right at the end, in the last 2 minutes or so, I showed you a topic of recursion. That's when a method actually goes and calls itself. Don't worry, you don't need to know it in your curriculum, but it will be pretty cool if you could find a way to implement those in your PAT this year. Whatever is left of this year, whatever the PAT is, I don't know. But definitely, if you can do it for next year, you can score some nice marks there. Okay, so today's lesson, let's just go to the next slide. Today's lesson is also pretty important because when you come to your coding and designing your PAT this year and also next year, there will be marks allocated for user-defined methods. And it's a great idea to use methods for validation, specifically to check validation. So you're going to maybe have a splash screen where a person's going to log in with his username and password, and you want to now start validating. You want to check, okay, before I check the database, if this username and password is actually indeed correct, I want to validate a few things. I want to check, did this person actually enter a username or a password before I actually go and send it on? So those are all validation techniques, and it's pretty easy and nice and clean if you can place that piece of code in a method itself. So today, coding functions to do basic input validation techniques. I think at this point, I'm going to just stop there and talk a little bit about validation. Now, you may have done this in theory at some point, but from my point of view, there's validation and then there's verification. Now, validation, all that validation does is it checks and ensures that your program doesn't crash. Okay, for whatever reason it may be. It checks that the data that is expected is following the rules. You can't just go, if you're supposed to type in your grade, you can't just go and type in Apple. And validation makes sure that you type the correct stuff. Now, some components lend itself that you don't have to validate. So let's look at the grade example. So anything from grade 1 to grade 12 is acceptable. And you can actually have a combo box. So a person can't actually type anything in other than the range that you specify in your combo box from 1 to 12. But if it was an edit, that's where the danger lies, and that's where validation comes in. Verification is the part where I actually go and check if whatever the user typed in is correct. Okay, so checking your database, if a person typed in the right username and password, that's not validation, that is verification. So the first step is validation. You're checking, did the person type something in, etc., and so on. And then after those validation techniques are covered and they're all true and it's fine, then I go to the database and I verify your username and password. Please note, you need to understand and differentiate between the two topics, validation and verification. You need it for your theory. They love asking those type of questions. It's a typical 4-mark question. So what validation techniques are we going to look at today? Well, the first one's the presence check. Presence check, really simple. Did somebody fill something in? The data type check is the data type that is entered expected. So that's the whole idea of typing in Apple when you're supposed to type in grade 11 or just the 11 for grade. Okay, and then there's a range check. Now, range check is a validation technique to make sure that you've entered something within a defined range. So I could also check for the grade. Did this person type in? So after I check the data, I could start off with presence. Did this person type in a grade? Secondly, the data type check, was it actually a number? And thirdly, the range check can go and say, okay, did this person type in a value between 1 and 12? Because -1, that's not a grade, and 13 is also not a grade. So that's the whole idea of range check, and we will look at the code for that. And then lastly, a little bit of a more complicated check is the checksum. And that just makes sure that, and specifically for numbers, if I'm typing in a large number of some sort, to make sure that, I can't verify, this doesn't verify if you type in the correct number, but it can check if you've done some mistakes while entering those numbers. Okay, so firstly, what is validation? I think I've touched on that, but let's just read what the DBE textbook says. It says, for data input, a validation check is used to ensure that the data received in the form is actually what is required by the application. Okay, not necessarily correct. If my name is John and I got to type in my name and I type in Gary, will it pass the validation checks? Yes, of course it will, because it's a name. But did it check whether it was truthful that I entered in? No. For that, you would need verification. And that could be a person actually employed by checking and comparing your ID numbers. And is this person actually John or not? Or it could be a system that checks another system like Home Affairs and makes sure. But this that we're doing today is simply just validation. Secondly, validation checks are a safeguard against incompatible values. So that's your data type checks. And if you don't check for this, what will happen if you type the wrong thing in? What will happen if I type in Apple? That could cause interruptions in the flow of the program or cause the program or operating system to crash. And that's exactly what will happen. My Delphi program will just throw a runtime error and say, oops, there was a problem. Validation techniques do not determine whether the data input is accurate, and I think I've covered that. That is what verification does, not validation. Different validation techniques are used to validate data input, and we're going to look at them. And then we will be exploring now those 4 examples. And I've made screenshots of the DBE book. I'm allowed to, it's free, and we can actually go through them. And please raise any comments if you think that the code in there could have been better. You know, if you think that, no, why is this happening? Or please throw a comment if I'm going too quick, or if you don't understand something in code. Some of these validation checks are lots and lots of code, but I will try and go through them step by step. Okay. So the first one is the presence check. So that is to make sure that somebody actually did enter something into my field, typically an edit or so on, when I hit my button. So, and here is a function that has been defined that does exactly that. So the idea is I have a separate function that will perform a presence check, and it's going to return a Boolean. So when I call it, I'll probably call it from the button. So the button says log in, and the button grabs the username field's value as well as the passwords field value. And then it would say, okay, Mr. Check Empty function, please check the following string. And what will I be passing? Well, I'll probably be doing this twice, once for the username and once for the password. So I would call, the button will call after it collected the values from the edits. It will say, okay, if check empty, and then my string that I've captured from my edit, then what? Okay, so if it's empty, it's going to return a true. So then you're going to want to give some sort of message saying, oops, no, you didn't enter a value, please try again. And if we have multiple validation functions, I can actually tailor my message. If I just had one huge validation code and it wasn't functions, you're probably going to end up with a true and a false, and you're going to say there's an error. But does that tell the user what the error is? No. If you have little functions, then they all have their little messages specifically to what went wrong. And in this case, I didn't enter something in. You can tailor your message to say, oops, you didn't enter something into that specific edit. Okay, so there we go. So we've made a function, check empty. I receive a value, okay, as a parameter, and I'm going to check that value if it's empty or not. So it's going to be a string, not an edit. I'm not going to be passing an edit. I'm going to be getting the value from the edits text into a string on the other side and use that value and pass it to this function. So what did they do here? So they create a Boolean variable they call flag, and they say, okay, I am going to make this flag true. Remember, I'm saying check empty. So if it's true, it is empty. Okay, and it says there, if b flag, or just b flag equals true, if s value, my parameter, is empty, then I'm going to make it false. What do you think of that? Well, personally, I don't like that, because for me, the English said check empty, true should be empty. So the textbook over here, in my opinion, is incorrect. We should have said b flag false. So we're assuming that it's not empty until I can prove that it is empty. And if I can prove it is empty, I would be proving it with if is value is empty, then I'll change it to true. And then I will return true. So there's another mistake here. Well, there's three mistakes that I can see. Two physical mistakes. Logically, they did this the wrong way around. My b flag must say if it's empty, not if it's not empty. Okay? Otherwise, I should have named my function something better, like is not empty. It makes much more logical sense. Check empty or is empty, and if it is empty, I return true. So that's the first mistake. The second mistake is this function never returns anything. You see that? It has a variable b flag, but it never actually ends off with result becomes b flag. So that's the second mistake in this one. And thirdly, is, as I said yesterday, I see there's a question from Scott or a recommendation. I'm going to come to that in a second. Thirdly, is I specifically said in my rules yesterday, don't bind a function to a GUI component. And this is exactly what this function is doing right here. It's binding it. It is forcing you to say enter a value or not. Now, how do I know? How does this function know what the form actually wants to do with this information? It may want to give this message somewhere else, maybe in a label of some sort, or maybe making the edit red. Now, because the show message, please enter value here, is here, this function is limiting what the form can do with its answer. Okay, it's sort of treating it almost like a procedure here, which I don't like. So what I would do is I would swap true and false around. I would not put the message in. I would simply return result equals whatever the result is, true or false. So the comment here is, wouldn't it be better to name the variable better? Rather call it bempty for clarity. Yes, you can. You can. This is a generic term, B flag, but I tend to agree with you there. I would call it bempty. And if it is true, then I know it is empty or not. And I would probably not call this over here check empty. I would call it is empty. Because if you're breaking a function that returns a Boolean, then it's usually a question. Because my answer is going to be true or false. So if I say is empty, then that makes a lot more sense. Okay, guys, so there's 3, 4, even 5 reasons why textbooks aren't always correct. They try their absolute best, okay, and it's still a great textbook, but it's not always 100% correct. And if you do pick up something like that, please ask your teacher. Please Google it. It can always, or sometimes at least, happen. I hope you understand the presence check. It's very, very simple. So the idea is, when I call this check empty, or in my case, I would have liked to call it is empty, the form now has an answer of true or false. And then the form can make its own decision what it's going to do with it. It can decide, I'm going to show a message. It can then say, if check empty is true, then show a message, or make a label with an error message, or make my edit red with an asterisk. Then it can do whatever it wants to. I hope that makes sense. Okay, so the next one, a little bit, there's a bit more variation here than the presence check, because the presence, is it empty or not? Okay, that's all. It didn't check if the data is correct or any other thing. So now the next type of validation would be your data type check. And this tests whether the data entered is of the required data type. And we learn in our curriculum 3 broad types. So the one is, I want to check, is what is entered an integer? Secondly, is it a real? Okay. And the last one is checking various forms of strings, like, are they all letters? Can I include spaces in my letters as well? Can there be special characters? I can actually expand that. Could there be numbers in this as well? Because a password should contain all of these things. And so this, where integer and real is pretty simple and straightforward, you will have to adapt your code in your exam based on what the requirements are here. Okay. So let's look at a data type check for an integer. So again, there's a function that has been defined, and it takes in 2 values here, s value as well as s field name. Now let's try and figure out why they want 2 values here. Okay, it's also going to return a Boolean, so true or false. So is valid integer. Now that is a good way of naming your function. So is valid integer, if it's going to return a true at this stage, logically, I'm telling myself that means that it passed the test. If it returns false, it means somewhere in that integer, I entered something incorrectly, like a letter or whatever. Okay, so let's see. So again, they create their B flag. Okay, at this stage, again, that's a generic naming convention. So I can't actually say at this stage what they're trying to say. So again, yes, Scott, you're absolutely correct. Give your Booleans a better descriptive name over here. And then they create an I number, an integer. So they start off by saying they're making B flag false. So they make an assumption before they do a test. They say, okay, if I'm going to assume that whatever is passed to me is indeed an integer. I'm sorry, is not an integer. It's say, yeah, let's just try again. If B flag is false, false is valid integer, I'm going to assume it's not a valid integer unless I can prove it otherwise. And that to me is already a red flag there. But let's carry on. They use the try except to check for integers. Now let's look at the try except here. What is that? It says try except section, the try section. Okay, so that's a bit of code underneath the try section. The string is converted to an integer, okay, and B flag is set to true, indicating the conversion was fine. Now that would make sense, correct? So what they're saying here is if I try to do the following, okay, make this value into an int and store it in inum, and it succeeds, what does that tell me? It tells me that a valid integer was actually entered. Otherwise, the program would have not liked that. And for those who don't know, a try block tries something. If it is going to throw a runtime error, then it would stop right there. It won't crash the program, but it would execute the except. So let's see. I'm trying to convert S value to an integer. If that succeeds, I will go to the next line. If it doesn't, I would skip that line and go to except. But if it succeeds, I make B flag true. Now that makes sense to me. Okay? So is valid integer. If it is a valid integer, it's true. But if this over here doesn't succeed, it stops right there and does this. There again, then I don't like the show message at all. Okay, it shouldn't be in a function ever, but they've placed it in. But what is important is they then make B flag false. So you, and at least the result is now equal to B flag. So that part is correct. I believe you could have reduced this. Can somebody think of how I could have reduced this code? Now, what I could have done is I could have said, okay, let's assume it's true. And then I try and do that. I don't actually put the B flag true in, and I just simply go to accept and B flag false. So the reduced version would have been, I'm assuming it's true unless this crashes, and then I make it false. But both of them will work. Hope that makes sense. Any questions? Okay, so let's move on to the next one. So this is where I check if it's a real number. Now again, exactly the same thing. By the way, I just want to go back one step here. I just want to go back one step. S value, comma, S field name. Now what's this S field name? Okay, they brought that in because they want to show a message inside the function. Guys, please, if you design it, listen to me. You only need the one variable. That is what I'm going to test on, if it's true or false. Don't bring in the field name. You can handle your message from the form. So this is actually something that you could have done with one parameter only. Okay, so let's look at the data type check for a real number. It looks exactly the same. It's got the same errors. I'm going to get to that question now. It's got the same errors as the previous one. The only difference is instead of the string to int for an integer, they now simply do string to float. Okay. So the question is, why did they set B flag to false twice? That's my question exactly. You didn't need to initialize the B flag at all, okay? Because you're either going to execute the try or the except. One of the two will actually be executed. So in the end, after I exit my except part, I will have a value for Boolean. Doesn't make a huge difference. It's a minute little process that happens. I don't think that would make a huge difference to even a large program. But yes, I wouldn't put that B flag equals false there. It's most going to be changed over here at the bottom. Okay, so the integer and the reals, pretty straightforward. We create a function, we accept a value, we test that value using a try, and based on if it succeeds or not, we make the Boolean true or false, and remember to return it at the end. Okay, the last one, checking for strings, a little bit more complicated because the exam is going to dictate exactly what you will be testing for. Okay, so this one, for a change, fantastic. There is no message in this function, so I like it already. It only has the one value as a parameter, and it's S value, and that is most probably what we will, definitely what we will be checking on. So somewhere where you're only supposed to type in a string with letters and space, so maybe a name and surname, something like that. That would have been grabbed from an edit, and this is valid string, again, nice name, is valid string A to Z. It doesn't say anything about space, but that's okay. And then I pass that string that I captured from my edit or whatever component I've used. So is valid string, the name tells me if I'm going to return a true, I'm expecting that the string is indeed valid. Okay, and it's going to return the Boolean type. So variables B flag again, and then it's got an I and an I length. The I is going to be as a counter, I guess. And the I length, well, let's see what they do. So we say there, we start off by saying if length of S value is not equal to 0. Why do you think they're doing that? So length of the string is not 0, then what? So they're saying only if something was entered into S value do you do that. Any comments on this? Now, please think back. Remember what I told you about the fundamental rules of making methods. One of those rules was every method that you make should only do one thing. Now, in my opinion, as small as it may seem, this method is doing two things already. This thing is already doing a presence check. Why do that? You could have called your presence check function right here on that same value, and it would have returned you a true and false. Okay, but anyway, they've decided to check the length as well to see if there's actually something in that string. Okay, so let's carry on. Where's my mouse? There. So they say here, begin I equals 1, and they say B flag equals true. I like this. It's saying I'm assuming that my string is valid unless I can prove it otherwise. Okay, so the moment I can prove that it's not valid, I will make it false and I will return that flag. So let's see how they go about testing this. Excuse me. So they use a while loop with two conditions. They say, firstly, while I is less than the length of S value, okay, so I'm going to, looks like I'm going to loop through the string one character at a time. So if it was John Smith, it will start with the J, and then the O, and then the H, and so on. So that's the first thing. So while I haven't reached the end of my string, and at the same time, B flag equals true. Now, this B flag equals true is not required, but it's actually a very smart thing that they're doing here. Very first time, B flag will be true, okay? But why is that placed in here? Anybody think? Well, the reason is I want to try and prove that there is something other than what is allowed in the string, and I'm going to check character by character. If my string has a length of 20, and I find that the third character is not a letter or a space, let's say it's a number, then at that point I've proved that there's something wrong, okay? I don't now have to carry on and loop through the entire string to prove my point. I've already proved it. So that is why we put the B flag in there. So the moment I can prove that it is false, and I go back into my while loop, that would then allow me to exit the while immediately after my third iteration. And it will keep me from going right to the end after I've proven that there's something wrong already in the third position. That's all what this does. So if both of them are true, I then go in and I say, okay, if not uppercase, so I make whatever this person typed enters in an uppercase. So I guess the idea of this is valid string. It doesn't care whether it's uppercase or lowercase. So you are just making it uppercase. And you're saying uppercase S value at position I. So the first position, then the second position, and so on. So we're treating this string as an array of characters. I make that character uppercase, yes. If there's anybody who asking right now, why uppercase? I thought it was uppercase. Well, there's two. There's uppercase that makes a string uppercase, and then there's uppercase that makes a character. It accepts a character as a parameter. And this over here is indeed a character because it's S value at position. So, okay. So if not uppercase at position I in A to Z, comma, space. What does this mean? So in says I'm checking if I'm in some sort of range. Now there's two ranges here. The first range is the range between A and Z. So all the uppercase letters between A and Z. Now I think uppercase A is round about 64, 65 or so, and I should actually go and check it. It's not the first time I was unsure about this. And that 65 is the ASCII representation of the character. And the Z would be 26 later. So if A was 64, then Z would be 64 plus 26. Okay, and that would be, what is that, 90. So then Z would be 90. So I'm actually asking is this character not in that range, comma, or a space? So if it's not in that range, or when it's not a space, not or, sorry, and it's not a space, then obviously I've entered in a number or a special character of some sort. So at that point, what I'm doing here, if it's not A to Z or a space, then I've proven that an illegal character was entered. And then what do? I make it false immediately. Thank you, Scott. So A is 65. I'll remember that. So then I make it B flag immediately. Well, if it's not, in other words, if it was a legitimate character, it's just going to increment. Well, it's going to increment in any case. So it's not an else scenario. It's going to increment in any case. And then I'm going to go back up. I want to increment for every single character. And I'm going to go back. I'm going to check, have I reached the end? Or have I proven that this is incorrect? Then I exit. What do I do? Oh, this B flag false, that was, if I remember correctly, that was this if statement over here. But okay, I said you should probably rather use a function to call that. But anyway, your result's going to be B flag. True, if I didn't find anything wrong. False, if I found something wrong somewhere, and it added this whole empty. It will also be false if it was empty. Okay, happy with that, guys? Okay, we've got 10 minutes left, but I'd rather go a lot slower and even carry on with this lesson on Monday if required, because it's important that you do understand this. Now, this thing over here checks where the cell phone numbers are. No, I can't actually even read that. Valid. Let's see. Now, a cell phone number, I think that is 10 digits long. So we're going to obviously do a few checks here. So my function T-validation class, so they've implemented this in a form called T-validation, dot is valid cell number. So there we go. It's a very nice wording or name for my function. So is valid cell number. If I'm going to return true, it means it is valid. If it's false, it's not valid. There's something else wrong there. So what do? Okay, they create their flag and some integer. As I think I've explained a lot after the cell phone, I think we'll probably call it a day, but just try and concentrate one more time. So what are we going to do? The first thing that they do is CS cell num. Now that is the parameter that was passed to me. Now I'm now going to do something with this. Looks like I'm changing it. String replace. Now what is that? It says use the string replace function to remove spaces from the cell phone number. Now, what does it do? It says, okay, string replace, look at cell number, and what it does is it takes two parameters, a space, and then there's some directive there, which means don't just replace the first occurrence, but replace all of them. Now, I think there's a mistake here. I think this string replace is applied on a string. It looks for all spaces and replace them with, well, it's replacing it with a space. So there's no point, is it? So I think the mistake here in the textbook is that you shouldn't have had a space. You should have opened your apostrophe and close it again immediately. And that gets rid of all the spaces. But saying there, what is Mr. Freeman's fundamental problem with this line of code? Well, I feel that it is doing two functions. This function is doing two functions, it's already replacing or taking away spaces. I would have said, no, create another function called remove spaces. And then you pass this very C cell number to it. It returns it as a string with a new cell number without spaces, and then you carry on. That is what you should do, but okay, I will look away and I will carry on. So at this point, we assume that our cell number has no spaces in between or even before or even after my string. So what are we saying? Are we saying if length is 10, and I'm just going to say we're assuming again that the cell phone is correct. It is valid. So if length equals 10 and a cell number at position 1 is a 0. Now that in my mind says that that is fine, eh? Because a cell number should start with a 0 and it should be 10 characters. Now what does this if do? Okay, so the if starts over here and then there's an else, and then the else says b flag equals false. In other words, somebody typed in a cell number of size 9 or 11 or something else, or they didn't start it with a 0, so I make it false. And here we go again with that typical mistake. They put a message in there. Don't put a message in there. I'm not even going to read that. Okay, but assuming that my length is correct and it starts with a 0, so that's the first check that I do. I'm now going to see if there's not something else wrong, because it could have the right length and start with a 0. But what if I have something else incorrectly inside the cell number? So we're going to say while C is less than or equal to 10. So I made C 1, okay, and as long as it's less than or equal to 10, so it looks like I'm going to be looping through every single character in what I've passed, the C cell number. And again, same reason as the previous one, B flag equals true. Because the moment I can prove it being false, I should exit this while loop. Okay, 5 minutes left, guys. Let's see if we can do this. Now, the question is, if not cell number at position C, so the first time it's my first position over there, if it's not in the range 0 to 9, note that the 0 over here is not a number, it is a character with the semicolon, with the quotations. That's what you use the in for. So it's a range from 0 to 9. Now, really, I don't know what 0's value is. I don't really care at this stage, but I know it is 9 less than 9. So I'm checking if that digit, every single digit, is in that range. If it's not in that range, I make it false. I don't put the stupid message, and I go out of my while loop. And then all the way at the end, I return my flag. So false if it's something wrong, and true if it's not. Okay, guys, obviously this type of validation doesn't cater for those numbers, those shortcut numbers where you go 0860 OUTsurance or whatever it may have been. That is a different type of validation that you would have to do for that. Okay, so that is this. I'm going to carry on Monday with the next one. And that is a date and time one. And this is very involved. This is where we're going to check if the date and time that was entered. So in 3 edits, you see the S day, I month, and S year, if they are valid. And we're going to go through a whole rigmarole to check if they are indeed. The day is correct. Think about February. Think about a leap year. Month is correct. As well as the year. I think that is pretty easy. So I may actually, for Monday's lesson, split this in 2 because it's quite small. I hope you can all see that. But guys, I'm going to stop at this stage and we're going to carry on Monday. And then we still have to do the checksum on Monday as well. And that is also quite a complicated little check. We're going to use the Loon algorithm. The LUHN, that's the guy who created it. And that is quite a common algorithm that checks if ID numbers that have been corrected are actually correct, or credit card numbers and all of that. In other words, did I not enter something in incorrectly somewhere? And it's quite an interesting, those who like the algorithms, interesting little algorithm to look at. So we're going to look at the date time on Monday, as well as the Loon algorithm, and then we'll probably only start coding all of this on Tuesday and most probably Wednesday as well. One final thing, from Monday, our slots have changed. The slot that's usually at 2 o'clock from Monday is going to move 2 hours later and it will be at 4 o'clock. I hope your brains will still be fresh by that stage, and I hope to see you on Monday. Guys, have a lovely weekend. I hope this all makes sense. If there's any questions, please start all of them on Monday with your comments and we can tackle it as we go. Have a lovely weekend.